feeling like sunshine, like springtime, like something's in the water and I'm taking a deep dive. I'm feeling so weightless, like I'm gonna make it, and nothing in the universe can take this. I can see it clearly now, nothing gonna bring me down. I got my head held high, I'm on my way, and I'm following the signs to my happy place. I'm walking in the light of a brand new day, and I'm right where I belong in my happy place. I got my head held high, I'm on my way, and I'm following the signs to my happy place. I'm walking in the light of a brand new day, and I'm right where I belong in my happy place. And I'm right where I belong in my happy place. And I'm right where I belong in my happy place.
Welcome to the National University of Singapore Yong Loo School of Medicine Healthy Longevity webinar. Thank you for being with us tonight. Professor Suresh Rattan is today our guest, a prolific researcher, advocate for the aging field, a mentor, and a good friend of mine. He will talk about the achievements of the biogerontology field, and I think also about its challenges. This is going to trigger lots of questions, so please use the Q&A function to start our discussion. As always, we are starting with a short presentation, this time by Jinjira So, our PhD candidate at the National University of Singapore. And she will talk about a very small molecule, glycine, how glycine administration might alter the function of physiological systems in humans. And she wrote a systematic review. Over to you.
Thank you for the introduction. As mentioned, my name is Janjira, and today I will be presenting a systematic review paper on the effect of glycine administration on the characteristics of physiological systems in human adults. This paper was published in the journal Neuroscience in 2023 by So et al. From our Center for Healthy Longevity. As the physiological implications of glycine administration at the organ system level in human adults have not been comprehensively assessed, the aim of this systematic review is to summarize the effects of glycine administration on the characteristics of physiological systems in adult humans. So what is glycine? Of the 20 amino acids, glycine is the simplest and smallest amino acid with a single hydrogen atom at its side chain. Glycine is found in foods, of which those that are high in glycine include fish, dairy, meat, and legumes. Dietary glycine intake ranges from 1.5 to 3 grams per day, depending on the person's protein intake. Glycine is one of the main amino acids in collagen, which is a primary building block of the body's skin, muscles, bones, tendons, and ligaments, and other connective tissues. Furthermore, glycine is a precursor for other key metabolites essential for biological functions such as creatine, glutathione, heme, and purines. In animal models, glycine administration has been reported to extend the lifespan of nematode worms C. elegans by up to 33%, of rats by approximately 20%, and mice by 6%. Given that glycine is inexpensive and likely safe for administration through oral supplementation, it is important to study its potential lifespan and healthspan enhancing properties. In the systematic review described, the inclusion criteria comprised of adults with a mean and/or median age of 18 years old and above, and administration of glycine in any combination of dose and medium through all reported routes, except topical administration. After the articles have undergone the screening process with duplicates excluded, 47 articles describing 50 studies were eventually included. The figure shows the summary of changes in characteristics on each physiological system in healthy and diseased populations with glycine administration. Overall, the majority of studies reported oral glycine ingestion as the mode of delivery. There were more studies conducted in diseased than in healthy populations. Glycine administration may improve the characteristics of multiple physiological systems, but there is limited evidence supporting their preventative effects for healthy populations. The mean or median age range for healthy populations is 21.5 to 41.4 years, and 29.5 to 67 years for diseased populations. Glycine was administered for a period of 1 day in a single bolus to 14 days in healthy populations and up to 4 months in diseased populations. The majority of the physiological systems demonstrated significant positive effects on glycine that were mostly related to the nervous system, with longer-term glycine administration, especially in diseased populations afflicted with psychiatric illnesses. The positive effects reported on healthy populations included improved sleep and decreased daytime fatigue and improved insulin responses. Conversely, negative effects were mainly reported in studies giving a higher glycine dose in a single bolus. This disparity in outcomes in studies on healthy populations may be attributed to variations in dosages and intervention periods. To conclude, glycine administration is most effective in improving characteristics of the nervous system, especially in ameliorating neurological symptoms in populations with psychiatric illnesses. Although the administration of glycine may improve the characteristics of multiple physiological systems, there is currently limited evidence supporting its preventative effect for healthy populations, which warrants the need for future research. It would be prudent to conduct more studies on healthy populations to particularly establish the optimum dosage, route, and medium of delivery, intervention duration, and timing of glycine administration for optimal organ function over multiple physiological systems to prevent the onset of age-related diseases or to delay and potentially reverse the aging process. Notwithstanding, the evidence to date may suggest a simple and effective preventative strategy to enhance health span through oral glycine supplementation. And with that, I'd like to thank you for your kind attention.
Thank you so much, Sanzira. Very nice review. And hopefully we can make sure that to answer the question if glycine is going to work in humans or not in stimulating and optimizing health. But that's not the topic of today. The topic is really talking about biogerontology. And Professor Suresh Rattan is with me, and he is emeritus professor at the Department of Molecular Biology and Genetics at the Aarhus University in Denmark. And he is really known for his research on aging of human cells, to really understand the concept, to apply mild stress to induce hormesis. He is the recipient of the prestigious Lord Cohen Medal in Gerontology from the British Society of Research on Aging. And he also holds an honorary doctorate from the Russian Academy of Medical Sciences. He published a lot, more than 300 scientific articles, and has authored many books, 23 in total. He either authored it, edited, or co-edited, including books that's important for children, our next generation, the general public, and research scientists. He is also the founding editor of Biogerontology, a prolific international journal. He is doing that since 2000. And he is also the present chairman of the biological section of the European region of the International Association of Gerontology and Geriatrics. Very importantly, he is also part of the Healthy Longevity Talent Incubator. Already 2 times he was mentor there, really nurturing the future of many researchers to come who will hopefully at a certain time take over our position, Suresh. So Suresh, thank you so much for joining. It's a pleasure of having you, and we are looking forward to your talk.
Hi, Andrea. Thank you very much for all your kind words of praise. I think it is the 135th lecture in this Healthy Longevity webinar series. An amazing achievement you guys have been doing since middle of 22 or even earlier. And you will be glad to know that I think I have attended at least 130 lectures on it. I might have missed 4 or 5. So I feel very happy that now it's my turn to use your platform and to be invited by you to share some of my ideas about and recapitulating biogerontology. So I think I should go to share my slides. And so recapitulating biogerontology and what challenges it faces. When we talk about aging, the old terms which come to mind are gerontology and geriatrics. These are the classical terms. Gerontology for the study of aging, the processes and consequences, and geriatrics, the clinical management and treatment of diseases in old age. So gerontology then was further arbitrarily compartmentalized into biological aging, or the sociological aging, or psychological aging. So the biology of aging then started being called as biogerontology, primarily when I started this journal, Biogerontology, in 2000. And although before that, I was using this term in my courses being given at the university. But since then, the term biogerontology has become widely accepted, and people who are working on the biology of aging, we call ourselves as biogerontologists. And the person who actually encouraged me or pushed me to start this journal, Biogerontology, was whom we also give the credit for being the founder of the modern field of biology of aging, or biogerontology, and that was Len Hayflick. He died a month ago on 3rd of August at the age of 96. And he was one of my mentors, and along with Robin Holliday. And one of my personal anecdotes with him is that for the last 25, 26 years, we were exchanging birthday greetings because we shared the birthday, 20th of May. So every year we will then exchange the greetings. So, and the magical thing happened this year, it's once in a lifetime thing, that when he became 96, I became the mirror image 69. So this is one of my mentors whom we lost, or the biogerontology community lost about a month ago. So this is my first lecture after his passing away. So in some ways, I dedicate this lecture to the memory of Len Hayflick, and it's my tribute to him. So biogerontology deals with the question of aging in all kinds of living forms, whatever those are. And what did Len Hayflick do? Actually give it a very solid scientific foundation. Between 1961 and 1965, he was able to demonstrate something very important, which then I have used this Latin term to match the famous Latin term omnis cellula e cellula, which means all cells come from other cells. And that was a great achievement by Virchow and other writers only about 200 years ago. What Len Hayflick showed is omnis senectus in cellulis. All aging resides in cells. Because until then, until about 1965, people used to believe that aging is the property of the whole body in general. And cells don't age. It's only a matter of finding right conditions, because there were certain claims for long-term or infinite lifespan of cells. But he demonstrated and convinced the world that, yes, cells, aging resides in cells. And that's a great, great achievement. And that's why we say that's when real modern biogerontology started. He used the term himself as calling them aging in vitro, or cellular aging. Then over the years, the term became more known as cellular or replicative senescence. In between, I think in 1970s, Sir Macfarlane Burnett, the Nobel laureate, gave these two terms in honor of Len Hayflick as the Hayflick phenomenon, that normal diploid differentiated cells cannot divide forever, and they go through a progressive change, aging, which ends up into this extreme senescence, replicative senescence, and other thing. And a lot of people were involved in developing this field in the last 60 years. And like some of the guys like Vince Cristofalo in America. And then there was Machiria Coelho Jim Smith and Olivia Pereira Smith. These were the guys who were using Hayflick system right from the beginning and demonstrated many, many new things in the early 70s. And then in late 70s and early 80s, then people like me came in the picture who used the Hayflick system to do basic research and get our PhD degrees like I did between 1979 and 1982 with Robin Holliday in Mill Hill, London, testing Orgel's protein error theory of aging using cellular aging model or Hayflick system for the Hayflick phenomena. Then around that time, also some other biogerontologists were emerging like Olivier Toussaint in Namur, Belgium, and Richard Farragher with Sidney Shell in England. So we were the guys who came in early 80s. And that's when, around that time, also mostly in Robin Holliday's labs and other labs, the ideas about telomeres and methylation were developing. In Russia, Alexei Lovnikov developed the idea of telomeres based on this Hayflick phenomena, which then later on was tested and developed by Kelvin Harley and was the basis of even the big corporation Geron by Mike West. So these were the guys who have been developing using this thing. And then then later on in mid-90s or early 90s, when the cancer biology people got interested in this phenomenon, because cancer cells could be maintained for indefinitely, whereas normal cell couldn't. And one of the main persons who came in the picture bringing all the technology and ideas was Judy Campisi. Unfortunately, she also died this year a few months ago. So these were the guys who then created such a plethora, such a development of the field. And then replicative senescence became a central theme. And to the extent that our host today, Andrea Maier, her entry into the field of aging was also by using Hayflick system, Hayflick phenomenon of aging. So Len Hayflick founded, in a way, modern biogerontology. But in the last 10 years, what has happened is very interesting. So the new terms and new ideas are developing very fast, whereas biogerontology encompasses all kind of life forms which undergo whatever way of aging. That can be Drosophila, nematodes, mammals, and other animals, even plants. But then in the last 10 years, this new terminology has evolved, where the focus is more brought towards human aging, because after all, we are more concerned about that. So geroscience and rejuvenation research, and more recently, longevity medicine, geromedicine, healthy longevity. These are beautiful, beautiful developments happening in the field. And I am I'm one of the great supporters of all those efforts, that what we want to do and why we want to do and how we want to do these kind of things. So it is in this context, I feel that sometimes it's important to zoom out a little bit and recapitulate what has happened in the last 60 years. Have we gained anything? Can we remember it, or are we totally ignoring it? Why I say it? Because in the last few years, this almost tsunami of this kind of intervention research has happened that I sometimes even consider it a kind of a gold rush. If you look around, how many longevity medicine conferences are happening, how many approaches, how many claims are being made left and right. A lot of them are very, very serious and very encouraging, but a lot of them can be totally hocus pocus, rubbish. So under that crowd of gold rush, before we jump onto the train, it's sometimes nice to zoom out and recapitulate. Now, who should do that? So here I use my privilege of being in the field for more than 40 years, but that now I have started feeling that I identify myself with the tribe of elders in gerontology. Yeah, the elders in gerontology, where I can share what I have understood, what I have learned, and I can afford to do that. It's not only my privilege, it's also my responsibility that I should try to recapitulate biogerontology and its future challenges. So, where do we go? When we use the word aging and old age, We all know what it generally means. It's generally that stage in life where things are happening downhill. And in the last 60 years, this biological aging phenotype, which emerges at some stage in life, is really pretty well described. There are hundreds and hundreds of papers and hundreds of scientists who have done it, from the population level to group level to individuals to systems, organs, everywhere. It's a huge area. Yeah, I have just picked up on some examples just to tell that there is almost everything known, but there are still a lot of things yet to be known. What happens at what level? Yeah, what modifications happen, whatever going around. And this is not a small achievement. So all this biological phenotype is very well described, and we can make certain general conclusions based on that. There are more dots to be put on I's and T's need to be crossed, but the overall picture is quite clear at the moment. And what is that overall picture? The picture is that aging phenotype, which emerges at some stage in life, is emerging intrinsically, is progressive, is heterogeneous, and individualistic. We all know that, but often we then forget it when we do experiments or when we especially want to intervene. So we'll develop upon that. And this is a great achievement, understanding aging at the biological level, the nature of aging. But what it tells immediately about the phenotype is that different species age at different rates or in different ways. Males and females age differently. Individuals age differently. Different parts of the body age differently. Different cell types age differently. Different cells age differently. Different molecules age differently. It's a messy situation. This is a very, very significant and important observation, because where is this heterogeneity coming from? First of all, what it immediately implies is that if I come to you with a magic pill, that please take this pill, and it will not only rejuvenate you and make you live for whatever ever, it will work on every part of your body, every kind of cell, every tissue. It will also work on all the people in your family, in the group. Please don't buy that pill from me. Then I'm trying to cheat you for the sake of making just quick money. This is a very, very important observation, this heterogeneity and individuality, because lots of things affect that end result of heterogeneity. And those are both genetic, what kind of genes you start with, and what were the conditions inside the mother's womb, which will affect 50, 60 years later and throughout life. What has been your life story? So that is where we also in the field of biogerontology sometimes talk about, we need to understand the evolution of aging, because different animals age in different time scales by our man-made time. Yeah, the biological time is different from man-made time. Every animal has its own life developmental processes, stages. So the question comes, is it evolution of aging we need to understand, or evolution of life? Because I think evolution of aging is not the right focus to question. It's very, very important to understand how life evolved and how it survives, and why can't it survive forever? Are there certain processes there? So that, and basis of life, again, I'm just showing this metabolic chart, is so intricate, is so complex, that the properties with all these processes at the metabolic level, they happen basically almost at the same time scale, man-made time scale in all kind of animals. The rate of protein synthesis or elongation per second is basically similar in all eukaryotes. The rate of DNA duplication, the rate of any of the metabolic processes. But biology is very different. So biology is, we all again use these words, is very dynamic. It's not static. There is no static state. This is the property of living system. They are alive and dynamic. We use the word homeostasis very just out of habit, but we all actually mean it's a very dynamic homeostasis. It's a dynamic, it's interactive, And it's self-regulatory by negative or positive feedback loop. And that's a very, very important issue. Both developmental biology people and aging people have tried to demonstrate, and they understand, which we often forget. And we should note that dynamic, interactive, and self-regulatory, if you touch on one part of this huge metabolic system, many other things will happen. There are processes of adaptation, there are processes of bypassing, there are processes of just ignoring. A lot of things happen, and that is where evolution has happened. Evolution has worked hard to create these perfect, well, whatever the systems, the functional living systems, whose lifespans can range whatever, from few minutes to hundreds of years. Now, and the evolution of survival mechanisms, that is where all evolution has happened. Evolution has not happened on killing mechanisms, although even for survival mechanisms, sometimes cell death mechanisms has grown, like apoptosis for developmental aspects, which is a survival mechanism. And that's where metabolism is there, which are fantastic. And then there are defense, maintenance, and repair systems, which evolution has in a way worked on under different conditions of different species. These are survival mechanisms. Yeah. So there can be a lot of similar mechanisms throughout life forms, which using George Martin's terms from aging research, which can apply to the developmental thing also, which we can call the public mechanisms, which can be seen in every kind of life form, or private mechanisms, which are those species specific, might be leading to that there are variations. So metabolism, defense, maintenance, and repair. And in the repair systems, again, there are hundreds and hundreds of pathways involved. There are hundreds and hundreds of genes involved. They all assure the survival of the organism. That is what is crucial for evolution. Evolution is not creating mechanisms for, well, I will come to that again, survival mechanisms for what we call longevity assurance. So such genes, which can be hundreds of genes, we don't know how many genes are involved in our basic health and survival. Yeah, but they are called longevity assurance processes or longevity assurance genes. I tried to coin the word vita genes also for that, but that didn't catch up. And those are evolved from evolution's point of view, which I call essential lifespan. What is the lifespan needed by an organism in its natural environment to live through its life stages and fulfill the purpose of life, if we want to use that word, Darwinian purpose, that reproduction and continuation of generation? That's the essential lifespan. Essential lifespan of Drosophila is maybe around 7 or 8 days. But in the laboratory, in a protected environment, it lives double, triple than that, yeah, or several fold more. A rat's essential lifespan from nature's point of view is about 1 year, but in protected conditions, laboratory conditions, it lives 3 years, 4 years. Same thing about our species. Maybe Homo sapiens' essential lifespan is around 45 years. And evolution has given fantastic mechanisms for survival. Then that gives another way of thinking about this all evolutionary evolved survival mechanisms in terms of life processes are dynamic, interactive. Yeah, they're dynamic, interactive, and to some extent self-regulatory. And I create these kinds of, because I've been doing a lot of teaching, certain ideas and concepts that we can think about these dynamic processes as homeodynamics, that a child is born with certain level of homeodynamics, survival responses, survival ability, which is still very weak in the case of Homo sapiens, but in many other organisms, it's maybe not that weak. Then it goes through growth, development, reaching a peak of certain homeodynamic space, which I call. So homeodynamic space, which basically is the sign or our measurement of survival, our ability to live, our ability. And the components of homeodynamic space are stress response, very, very, very important component. How internal and external challenges disturb our system, and can we survive it? The real life, the real health is actually found out when we test it under stress response. When there is a new infection, who is the one to collapse earlier? Yeah, that determines whether you are having a good homeodynamic space or compromised one. Stress response, I will come to that a little bit more later on. Damage control, all the time, damage is happening inside and outside. The three basic things which are necessary for our survival, oxygen, food, and basic biochemistry, they are also creating a lot of damage all the time, and damage control mechanisms. Hundreds of genes involved in that, and constant remodeling, the sign of homeodynamics. Not homeostasis, but homeodynamics. I am the same, but I am different from yesterday or from 10 years ago. So all these together, this concept of homeodynamic space, which is also can be used in other terms, which is a measure of resilience or robustness, is what determines my survival, which evolution has, as a part of the Homo sapiens species, given me a reasonable extent for about 45 years. But after that, what happens after that? There are no genes which cause aging. Evolution has not created any gerontogenes. This was the term I introduced in 1985. Just for the sake of competing with oncogenes. But then we find out that gerontogenes do not and cannot exist. At the most, they can be virtual gerontogenes, which later on I modified. And I'm glad to see that now, after almost about 25, 30 years, there is a further development in thought happening. And Andrea has published an excellent paper with Guido Kremer on further development of these terms into gerogenes, whether they are gerosuppressors or geropromoters. But evolution has not basically created genes to kill the individual. Some people can argue about it, or we can again talk about it, but this is how I understand that gerontogenes don't exist. But still, aging is happening. When we carry on living beyond essential lifespan, more and more aging happens, and it will create problems. And why it keeps on happening? Because all these repair mechanisms are there. If they were working, it should not happen. And that's where another important understanding from aging research comes, that biological processes, like everything else in the universe, are imperfect. There is no perfection in the universe. If we believe or we understand the theory of entropy or the ideas of the change, that immediately shows that there is no perfect state. If there was perfection, there will be no evolution. Biological processes are imperfect. Evolution has worked them so that they should keep us alive as a species level, not at individual level, but species level. But then these processes can and do go wrong. And they are the same ones which create the role of either geroprotector or promoters, yeah, like the virtual gerontogenes. It's the same genes which are there to keep us alive become eventually, in a way, the targets where things are going wrong and things may need to be changed. Now, remember the changes happening. Now, this is another way, my way of understanding aging, that aging is a shrinkage of the homeodynamic space. That's what aging is, which is not happening earlier. Aging is not just passage of time. The first part of the passage of time in life for all animals and for us is growth, development. Then the second part after essential lifespan is the aging part. And it's a shrinkage of the homeodynamic space. Our stress response abilities goes down. Our damage control abilities go down. Our constant remodeling immune system and everything else, they are becoming weaker and weaker. And the reason is because they were not made perfect. So when we say that Drosophila ages very fast or a rat ages very fast as compared to human beings, no, it ages in its right way within its own species history. Each species has a biological history and it takes biological processes. But if we use the human time scale, then yes, it looks like, a dog's 1 year is equivalent to 7 years of human life or whatever, 30 years of rat equal. Those are other way of thinking. Yeah. So aging is shrinkage of the homeodynamic space. Now comes the second part, or very quickly I will have to go through, that if we want to do something about this aging, which evolution hasn't caused it and it's not helping us to protect it, although a lot of things happening during aging can be even adaptive, because body is trying to survive. Please remember, there is nothing in the body which is trying to kill it. Body doesn't like to be killed. So, but it happens. So then what do? Then we have to help it. So that is where modern research in the last, this geroscience or anti-aging or whatever you want to call it, they are looking for these single targets, stimulators, inhibitors, stabilizers, removers. There are more than 250 or 300 compounds in the geroprotector database. Which one, any of the scientists will stand up and say, this is the one, I call it miracle compound. Not even rapamycin, about which we talk about a lot. Because those single things we ignore this question of interaction, bypassing, adaptation, compensation. So single things can have fantastic effect, but if we want to go from the bottom to upward, that is very, very difficult. And people, scientists like Andrea and other people at various places are realizing that. They have realized that we cannot just go from one molecular target to the end result by wishful thinking. You have to go through by understanding all aspects of biogerontology. And that's where this year I stuck my neck out by pointing out certain major conceptual challenges, the knowledge gaps which we need to have. And I will quickly go through the main categories. That evolutionarily, we still cannot explain why different species go through aging at different speeds and manners. Yeah. Basically, this question arises even to the evolution of essential lifespan. And then even the sex-specific differences, why males and females age differently. And then what are the imperfections? What are the limits of imperfections in evolutionary terms, which only give that much essential lifespan to the species? Then comes that within the same physical time, how different processes represent themselves in biological processes. And then what are the features of homeodynamic space? We don't know how to quantify it. How do I know that my homeodynamic space is better than yours or poorer than me? We need to understand those gaps. Then comes all these measurements which come, especially molecular damage. What we don't know is how much damage is doing what consequence, and how much is actually relevant or irrelevant if we want to do intervening. We have never done any titrations. We know hydroxyguanosine increases with age by 5-fold, but if I can reduce it 3-fold, do I become younger? Or the telomeres, or the methylation column, from molecular to physiological level. And then coming basically to other levels. So the final point I quickly want to make is that when we talk about aging and health, generally when we talk with scientists or other public, if we want to give any advice to public, we normally say, okay, so there is food, physical activity, these are the two biological strong interventions, and social and mental engagement, which are the pillars of health. That just basically means that we need these holistic kind of whole body approach. Food is not a single target approach. So physical activity is not a single target approach. So this is where the idea of hormesis comes in. Hormesis is this biphasic dose response, where everything which can be very dangerous at certain level, at a lower level, is actually the principle of life or the stimulation of life. So this is, I already mentioned that what are important things for life? Oxygen, food, and metabolism. And what are the causes of aging and death? Oxygen, food, and metabolic processes. So that is where hormesis comes. It's the matter of biphasic dose response, which are the beneficial aspects and where things can go wrong. So it's a hormesis strengthens everything, and exercise is the paradigm. Exercise not only improves your local muscles, it improves your cognition, your immune system, your libido, everything. And that is where hormesis works, by inducing stress response pathways. A lot of things are doing that. Physical exercise is one example. It is only good because it produces lots of free radicals, which then initiate a lot of other stuff. Like the same thing happens in various other compounds. We may often talk about antioxidants. Most of those things in the food, which we call antioxidants, they are not directly antioxidants like the direct chemical scavengers. No, they are indirect antioxidant. This terminology was created basically by Professor Barry Halliwell, direct antioxidants and indirect antioxidants. We call these things which induce stress as hormetins, as drugs for health, which can be from food, which can be from physical activity, and from social and mental engagement. There is further development happening. We are trying to create nomenclature for that thing if you want to develop multiple hormetin categories. So finally, the statement I would like to maintaining, strengthening, and recovering homeodynamics and health. Care about health. Don't worry about the treatment of a specific disease. If you maintain health, the body will take care of the length of lifespan, health span, total lifespan, and absence or appearance of diseases on its own. So aging research is into this category now, where we need to talk about health, sell health, promote health without fear, without frightening people with the dangers of diseases and all that. Take care of health, things will happen. And I'm happy to see that lots of people, well, I would like to have everybody turning into that. This philosophy is now working in. That's why the term healthy longevity, longevity medicine are coming up. But maintaining health, celebrating health is the center to understanding aging and continuing for a happy, long life forever, if that's what you want. I stop here. Thank you.
Thank you so much, Professor Rattan. Suresh, I forgot nearly how energetic you are. It's really fascinating how much wealth of knowledge you have, really capturing the entire history of what we did as a field in the past 60, 70 years, and how much progress there will be in the future. Let me ask you the first question. You had a quite enormous statement that biological processes are imperfect, and that if it wouldn't be imperfect, there would not be evolution. So that's the reason why we are not looking like we are, because there is a huge evolution, of course, ongoing within the human sapiens. How imperfect is the human body?
Well, it's obvious it's imperfect. It cannot live forever. It doesn't live forever. All the time, things are going wrong. Yeah. It is imperfect, because so what more evidence I can give you that there has not been, all living systems are imperfect, because we don't have any example of immortal living system. There can be shorter or longer lives. So imperfection is inbuilt into all natural phenomena, as even implied by quantum physics. Yeah, that nothing can be accurate 100% of the time. Entropy. Yeah, we cannot maintain a state because there is a disorder which takes over. So imperfection is basically intrinsic to all universe. Well, at least in our universe, I don't know in the parallel universes. If change is there, imperfection is intrinsic to that.
Yeah, but you know, we have colleagues who are immortalists. Obi de Grey, for example, stating that the first person living forever is already on Earth. So my question really for you is it or would it be possible that we are moving from imperfection to perfection? And the second question is, what kind of consequences would that have for example, evolution? There might be no evolution.
Okay. Yeah. We are not moving from imperfections to perfection. First of all, that's not even theoretically. We are talking, if we ignore all physics and quantum physics and all those thoughts, then yes, we are trying to, in a way, fine-tune imperfections for whatever purpose we want. We have done that already by biomedical achievements, by finding ways of developing hygiene, by taking care, by immune system, all those things. We are dealing with imperfections, but we can at best try to, in a way, fine-tune them to what is the purpose we are having. Yeah, if the purpose is to gain a lot of publicity, then yes, please talk about immortality and perfections. I also created a formula for a children's book where I create how to live forever. It's called E equals GMC squared. That was just a play on Einstein's theory. But where the conclusion basically reaches, even if you have fantastically optimized genes, fantastically optimized milieu M, that is where again this physics takes over, that the chance will kill it at some sooner or later. So that is one thing. We are not working towards perfection. Nobody's working. If somebody says we are working, the agenda is different. Now comes, if we start living very long, in terms of those thousands of years, which you mentioned, Aubrey, our great friend, great intellectual, but very provocative, because I think he did a great job by making these statements from 2003 onwards when he emerged on the field, because it drew the attention of people. That these people, scientists, are crazy. It has done a lot of bad effect on, backfired also on biogerontology, but he drew attention that, oh dear, is that what's happening? So that is his great contribution, to draw attention. But other than that, it is actually, I think, not a very nice thing to promote, because we also have to deal with the human psychology, the way populations have grown, what is our anthropological understanding of human being, what makes us human. And people react to that kind of even word. That first person to live 1,000 years is 160 at the moment, or 60 at the moment. No. Those are okay as a fun part, as a journalistic part. But those things are not going to be possible. In which time scale, I wouldn't like to put my money on any of that. I won't say it's impossible, but yes, we might be able to increase lifespan and health span more and more. Remember, the present record of 122 months, 122 years, 5 months and 14 days, set in 1997 on 4th of August, the date when Hayflick also died, is nobody has come near to that. Do you think there should be something happening? There are millions of people who are trying, so we should get some evidence that things are happening. Maybe we have already doubled up the lifespan in 100 years. So the next diminishing returns, that's where people like J. Olshansky, etc., have been talking that what are our now returns? How much more we need to do if we really want to change these numbers on the age scale. But yes, the quality part, that is where it becomes most important and urgent. I'm getting old. I would like to have better quality of my life in old age.
Sure. So let's do not then thrive for perfection, but let's tweak on the imperfection. I would love to hear your opinion about when to intervene. So, we are at the moment intervening, or try to intervene, when we are already aging, at the age of, sometimes even most of the randomized control trials at the age of 50, 60, 70. What is your opinion? Should we intervene during the growth phase, or should we intervene during the aging space? And the aging space is so big. When is the right intervention phase, with possibly the right of the most important return of investment people could have?
Yeah, that's the most important and perhaps most difficult question. Yes, from evolutionary point of view, first of all, during development and growth state, we have to be able to produce our homeodynamic space to as much optimality as possible, as provided by our chance lottery of normal genes. In the absence of any clear-cut disease or rare disease, we are all healthy, but we don't know whose homeodynamic space is better or stronger. So that part in growth, development, by nutrition, by care, by physical exercise, by all those things, by protection against diseases, is very, very important to reach our genetic-based homeodynamic space. But then comes the reproductive phase, and there are lots of data indicating that if you are so obsessed only about the physical health at young age or the reproductive age, you have to pay the price in terms of fertility and continuity of the species. So maybe after reaching an optimal or strength, the word optimal is very difficult for me to use. I don't like to use it, but I'm using it because it's a very personalized and individual. Then comes, when shall we start from evolutionary point of view for interventions? Most of the things appear to happen. Like there was a very recent paper about a month ago, the peaks of changes happening around age 40 and then 60. Just around essential lifespan, a lot of things were going up and down and up and down. And then a second wave comes. So already almost 20 years ago, I started picking up a number somewhere around 40, because the essential lifespan of our species is 45. So that is where the accumulation of disturbances, damages has started now showing certain variations. Of course, there is a large individual variations depending upon what you are doing. For an athlete, it's different. For a gymnast, already age 20 is old age. She can't now go and jump around. Yeah. So from most of us point of view, age 40 is evolutionarily argued right time to start taking care of your health more and use the technology, use the medicine, use any of the promised products, whether they work or not, from around that time. And for research also, I think between 40 and 45 will be a good starting point to see, because at that time, homeodynamics is still responding very well.
Okay. And I think there was a paper very recently actually showing that there the acceleration of the aging process of what we can see is actually happening at the age of 40 to 60. I can tell you, I feel it. But anyway, you already said that it's very unlikely that we all at the age of 40 will take one pill, one molecule, one solution, because of our very heterogeneous genome we have, how we handle life, where we live and what kind of stresses we are attacked towards too. So I would love to pick your brain. How can we now establish a field where we are taking all the interactive, dynamic, self-regulatory systems into account and working towards precision geromedicine that we can apply in the end, the right intervention at the right time with the right dosage, with the right frequency, etc., for that individual? How would you design that trajectory towards that establishment of that new medicine?
Yeah, very, very important. And that's what you are doing, Andrea. And that's why I am one of your
biggest... I would love to hear your opinion.
That's why I'm one of your biggest supporters. That's where we start from the biological and all these things. But in our case of human beings especially, we have to be absolutely aware about the social and psychological aspects of human life. What gives value to my life? What is important about my life? Whatever other plans are being made, testing single targets, multiple targets, single molecules, multiple molecules, food, whatever, they're all fantastic. But if we ignore, actually, last week's lecture by Professor John Wong was amazing. I really loved it. He was talking about Singaporean housing, how important that is. Where do you live? Economic basis, all these things, and the incentives. Why should I be healthy? What for? Don't tell me that I should be healthy because otherwise I will become burden on the society, because I will need more drugs and help. Yeah, I have worked for 40, 45 years. I have paid my taxes. Society should take care of me. What else? Why should I be treated as a burden? But we need to promote health. We cannot promote health by creating fear, which we have been doing so far. It doesn't matter. We need to also promote health, educate people, take their psychological needs, do all these technologies, and also talk about health, that health is not a perfect absolute condition. Health is one of the definitions which we developed based on psychology, philosophy, other things, that health is basically, it's not an absolute physical and mental independence in daily living. It is adequate physical and mental independence. Now, what is this adequate? That's where psychology and my personal needs come. What is adequate for me today will be changing tomorrow, and or even during the day at different times of the day. So I should be able to use all the technology, all the medicine, every kind of thing without feeling guilty. If my ears are not now listening to the sound correctly, it's okay to use the earphones or some hearing aids, just like I started using glasses. But sometimes society makes us feel that we have to be perfect. No, we don't have to be perfect. We have to be adequate. We need adequate health, but this is a very personal, again, achievement. An adequate health, my extreme example I give is that maybe one day adequate health for me will be to be able to get up in the morning from my bed and reach the toilet in time.
Yeah.
That will be a great achievement. Yeah.
I see many questions come.
So those processes which you guys are developing and your international network, a lot of people in America and the Russians involved and you guys involved. I am one of the greatest supporter of all those ideas. But now I am the elder in gerontology. I can inspire and maybe advise if somebody wants my advice. But yes, this is where we are going to lead to. We are not going to live hundreds of years or thousands of. Let's first aim somebody to break 122 record. I don't know when that will be broken. The oldest lady is only 117. Yeah.
I see that many questions are coming in, and I would love to hand over to Denise Ong. I had one last question for you. What should people do who want to be you in 40 or 50 years' time? But I think just reach out to Suresh Rattan and get the mentorship and advice. Denise, over to you.
Thank you, Professor Suresh and Andrea, for the lovely presentation. Just a few questions from the floor. How can hormesis such as nutritional and physical stressor be effectively integrated into biogerontological strategies to enhance health span and longevity? And what are the potential mechanisms behind their beneficial effects?
Yeah, well, we already incorporate hormesis in health, physical exercise. Is there anybody in the world who does not know that they should be physically more active? Is there any country in the world which does not promote physical exercise? Yeah. So that way, hormesis, physical exercise only gives a meaning if we understand the phenomenon of hormesis. So that is already part of it in all cultures. Now it becomes important. Why don't people do it? What are the incentives? Do we need to make exercise on a receipt that you don't have? There are all these things. Then the other part of the hormetic or hormetin, so exercise is a physical hormetin. Then there is a lot of things in the food. That's where most of the supplement industry is working. Although they keep using sometimes the terms antioxidants because the effects can be antioxidative. Yeah, just like curcumin. It's not a direct antioxidant, it's a hormetin. It induces NRF2 pathway followed by hundreds of antioxidative genes. These days, people are obsessed about autophagy pathway by rapamycin or other. A lot of these will be hormetins in the food, and there is a lot of research and development happening, combining one pathway with other pathways because we don't eat one compound in a food. So when I eat even curcumin, this is part of this turmeric, and turmeric is used in the food. And how should we improve our food, incorporating the principles of hormesis? That is where we need to think about and create, and it's possible to do that. But remember, food is not just nutrition. Nobody eats nutrition. We eat food, and not even food, we eat diet. So the old saying that we are what we eat, that's actually not correct. We eat what we are. You can give me this fantastic Mediterranean diet. Within 7 days, I will be depressed. I won't be healthy because it's not a drug. We eat what we are. And that component has to be involved in research also. When you give advice to people about their food, what kind of background they have. We can learn some of the things. I hated salads, but then due to certain reasons, I have started at least pretending that I like it. So Hormetins, hormesis are very, very powerful approaches. And the third part of hormesis is also social and mental engagement, which also works through challenges. Because this stress, we use the word stress, but actually it's basically kind of challenging the system. That's why if we can manage it, we succeed. This approach can be promoted, taught, and analyzed in the research results also. That is things working in a biphasic response, in a hormetic response, or is it just a magic compound?
Okay, so the last question I have here is, given the dynamic, interactive, and self-regulating processes, would you encourage researchers to focus on estimating the causality of composite risk factors such as diet, physical activity, sleep, or the entire lifestyle interventions on heart outcomes that are meaningful to patients or populations?
Well, we can have a combination of both. That if we can have an overall my systematic profile of various things, but while interpreting it or while advising me, it is very, very important to personalize it. We all talk about personalized medicines, etc., but we end up again into larger or smaller groups. The problem there is we still don't know how much information we need about an individual to really tailor the stuff. So yes, considering if we are dealing with a human being, considering human being as an independent entity and listening to her wishes, her choices, her aims, what do you want to do and when? And these things can be combined and should be combined. And I think more and more at the public health level, combining sociology, psychology, biology, clinical sciences, those will be giving us fantastic doors towards better health if we want to celebrate health. Although the question still stays is, why should I be healthy? What's wrong in being sick?
Thank you so much, Suresh. Thank you so much, Denise, for handling the questions. I think we can only summarize this webinar by don't strive for perfection. Imperfection is good. Suresh, thank you so much, not only to be a very nice friend, but also to be a mentor. You touched on the Hayflick limit. Len Hayflick was also somebody I really looked up about, and you, I think I told you 30 years ago when I read my first article, it was yours. So thank you so much. It's an honor to have had you here on the show. Thank you, everybody, the listeners, for your interest in our webinar. I hope you enjoyed this as I did. Please use the chat function to leave any comments and feedback. Please also follow the NUS Academy for Health and Longevity. We have lots of updates on our website, which is longevityacademy.sg. We have an intensive course for healthcare professionals. We have the Health and Longevity Talent Incubator, and all two are open for applications. The next webinar will be on September 19th. Our guest will be Associate Professor Sarah Haig. She is from the Karolinska Institute. She does wonderful research on building biological clocks. And as always, there is one final video for you, and that summarizes that you can never be too old. So hopefully you enjoy your life and take care.
My name is Charles To Chai Soon. I'm 93. I think that I enjoy most is that keep contact with patients who have different problems, different social life, different medical health problems, and many of them come from foreign countries. And that also is very interesting to me. I mean, I'm very interested in history.
He also does not have a computer at his work desk.
Can you imagine patients sitting in front of you, you talk to him, then you look at the screen all the time, trying to trace the record and all that. To me, that's a little bit impersonal sometimes, you know. I mean, I'd rather talk to the patient in the face.
Dr. To also relies on a diary for his appointments.
I use it for recording friends and patients' name, IC, phone numbers, and of course medication they're taking to remember. Write down my appointments and meeting times and all that, which is of course nowadays available in handphone, but I find it easier in the book because I can flip it much faster.
Dr. To does not have any plans to retire just yet.
From the health point of view, you should continue working if you can. Doing nothing, retiring at home, watching TV is very unhealthy. But unfortunately, in certain areas, certain professions, you have no choice. Surgeons have to retire earlier because they depend a lot on the technical skills. But in the case of a physician, we are really most of the time prescribing and giving opinions. My sons are happy that I continue working. I'm not a burden to them. One of my sons is a doctor, so if I keep up my medicine, I keep closer touch with him. They never say anything. They left it to me completely.
I'm feeling like sunshine, like springtime, like something's in the water and I'm taking a deep dive. I'm feeling so weightless, like I'm gonna make it, and nothing in the universe can take this. I can see it clearly now, nothing gonna bring me down.